Hi, everybody. AI is everywhere. Some of it good, some of it not so good, and if you've ever watched a science fiction movie, some of it downright evil. Well, the good news is if you're trying to use AI for good and you have the data available, Oracle has made it very easy to start using AI in your applications to perform inferencing on your data. Check out my next video and see how. Analytical AI, in a lot of cases, come down to two broad categories of functionality. You have training, which is where you gather the data and use a machine learning algorithm to figure out the rules that will allow the computer to make a decision about that outcome. And you have inferencing, which is where the AI is basically trying to figure things out for you. Now, this is an oversimplification, and there are a lot of other aspects to AI. But for the purposes of this video, those are the two important aspects. Get the model trained on the data so that we can then use the model to make a decision for us. The first part, training, is where you typically are going to have a data scientist and data analyst doing all kinds of work on that data. The second part, inferencing, is where the programmer steps in and puts the AI into the application. Now, I am not a data scientist. At heart, I'm a developer. Always have been, always will be. So how can I leverage AI in my applications without having to hire a data scientist? Well, the answer is Oracle Autonomous Database. Now, to be clear, I am not saying Autonomous Database is going to replace data scientists, not by a long shot. But for some of the more simple use cases, Autonomous can help bridge that gap. All right, let's talk about use case. Let's say I have a bunch of IoT sensors out there that are attached to refrigeration units. These units have been reporting data back to me for months. The data includes a timestamp, a sensor ID, a temperature, and an indication as to whether that sensor ended up in a fault state or not. What I want to do is leverage AI on the sensor data as it's being streamed into my application to predict whether the sensor should be recorded as being an anomaly. Now, I don't happen to have a collection of IoT sensors out in the wild, nor do I want to wait 3 months to film this video. But what I do have is a seeding script on GitHub. Now, I've used this script to generate some data here, and I'm going to use this for this example. Obviously, it's on GitHub. It's free to use if you want to try it out, make the modifications, even contribute if you want to. What I have done is created the data here, and I'm going to use this to load into Autonomous Database in the next segment. Okay, so here I am inside of my Oracle Cloud account, and the first thing I need to do is create an Oracle database. So I'm going to go here to the hamburger menu, select Oracle AI Databases, and Autonomous AI Database. And here I'm going to go create a new database. I can accept the database name as it is. It doesn't really matter at this point because this is a development workload, nothing for production. For workload type, I have a bunch of different options here. I'm going to choose transaction processing. Now with Autonomous Database, you get the same database engine under the hood, but it is optimized for different workloads depending on what you're trying to do. So you can have either a data warehouse or a transaction processing, a JSON database, or Apex if you're doing low-code Apex development. I'm going to choose developer just because I'm going to stick with low requirements here. This is a development project, so it's not going to have a huge amount of resources. For database version, I'm going to switch to 26 AI and get the latest version with all the latest tools. Going to obviously provide a password for your database. And I'm going to choose the option for secure access from everywhere, mainly because I'm going to be running the code here on my local machine for testing. and I'm going to hit create. Now, this is going to take a few minutes to do. You can see here it's provisioning, and we'll jump back to it once it's done. All right, it's been a few minutes. I paused the video, and you can see now that the database is up and ready. I'm going to just record the name here in my scratchpad. Now, one of the things that is really nice about Autonomous Database is all of the tools are actually built in for a lot of the things you need to do. So what I can do here is I can go Database Actions, SQL, and I can actually start exploring my database here. Okay, so there's a SQL browser and execution environment already built in. The other thing I can do is I can go here, view all database actions, and I can load data. So this has automatically got the data loading tools in here that I may need to pull data into my database. What I can do is I can take the file that I had that I showed you before. It's the sensor data. It's just a simple CSV file. I'm going to have a look at the data import, and you can see it's automatically picked up the rows. There's a timestamp, device ID, temperature, and the anomaly flag. I'm going to include all of those. And it's even automatically picked up the format of that field that I need, along with everything else. Now, I've done this a few times, and it's pretty much the way I want it. I have the option of creating a table, or I would have the ability to insert into a table or replace data if I wanted to. So a whole bunch of options here, all ready to go without having to invest in any extra tools. Now with that, what I can do is just say start and run the data import. Now there's about 65,000 files or records in that file. The 65,000 columns actually finished. So we can see we can get a report. We appended the data, 65,000 records were successfully imported. So I can swap back over to my SQL view, and I can very easily have a look. And if I want to filter, quick and easy, I've got my data into my Autonomous Database, ready to go and ready to start training with AI. And I can browse and have a look at the data, which is very helpful. Now, one thing I do need to do is I need to make sure that I have a database user that I can get access to and do all of the AI actions that I want to do. It's recommended that you do not use the default administrator that is baked in. You want to create your own user here. So I'm going to go database users, and I'm going to create a new user. We'll call them AI user. Okay, now a couple things you want to do here, or two things you really want to do. You want to turn on your REST access and your OML access. OML is your Oracle Machine Learning access. This is going to allow us as this user to go in and start accessing all of the AI tools that are baked into Autonomous Database. All right, I'm going to go, and the other thing I want to do is I just want to set their quota to unlimited, and then I'm going to say create user. Now, there's one thing that always catches me out whenever I try to do this, and that's permissions. I just created the database user, as you saw. However, I haven't given that user access to the database table with all the data in it. So we do need to jump into there and do that before we can move forward. So what we need to do is in the SQL, all sensor data or to okay, so then the next step is going to be, we're going to set up and train the models. So what we can do is here from the autonomous database, we're going to go database actions and view all database actions. Under development, I'm going to choose machine learning. Now I need to make sure that I sign in as the AI user. Not the admin, because the admin is going to be blocked from doing a lot of the auto ML features here. So I'm going to click sign in. Now from here, I can go to auto ML. Now, AutoML works on this concept of experiments. What happens is you set up an experiment, you tell it what you want to do, and then it goes and evaluates a whole bunch of models for you and tells you what the best one is. So I want to create a new experiment. Give the experiment a name. I'm going to say predict failure. Provide a comment if I want to, and then I'm going to choose the data source. Okay, now the data source was created in the admin schema, and it's sensor data. There we go. Now, what I can do here is it showed me the columns that down here, the features. I'm going to choose a prediction type. Now, first I want to choose what it is that I want to try to predict. What I want to predict is the failure, so anomaly. And there's prediction type, there's classification or regression. In this case, I want to choose a regression because I want to figure out if it's beyond the normal, the outside boundaries of what is normal. And it's going to automatically pick the features that are available. So the anomaly is what I'm predicting. Device ID is just the ID for the sensor, and temperature is the value. Now, I know that temperature is the value that's really determining it, but let's pretend I didn't know this. So I can have both options here available, device ID and temperature. Okay, now I've got all the parameters set up. I want to actually launch the training job. So let's hit save. And now you've got two options when you start training, faster results or better accuracy. I do tend to find it works a little bit better if you try faster results first and let it go through its process and then retrain for better accuracy. So let's try that now. And you can see it's actually running now. And it's going to go through a process, and you'll see that faster results actually is quite fast. It's gone through, and it's going to do some quick training. I typically find that this process completes within a few minutes. So I'm going to pause the video, and we'll see how it goes. And here we go. You can see that the entire process, once it got initialized, and actually started running, only took about a minute afterwards to complete. And we'll see here there's a bunch of data that shows us different models. So it selected a few different models, and the ratings for errors, as well as picking out that temperature is obviously the most important aspect of that comparison. Now, Fast training is great. It shows us the results. I want to actually jump in and do much more detailed training because I want to get some better accuracy out of the model. So I'm going to do that. This process is going to take substantially longer. So we're going to launch it and then come back in a little bit later. All right, so as you can see here, the entire training process actually took 11 minutes this time, so much more than the 1 minute it did before. Certainly not a long time, but again, we've only got 65,000 records worth of data, and it's a fairly simple comparison. So we can now look back and see the training data, the training results have certainly been updated some more. So you can see here there's two models that look like the prediction's going to be very likely to be very good because the error percentage is pretty much zero based on those, and even the others are fairly low. We've got these models, they've been trained, so the next thing that we can do is actually deploy the model so it's going to be useful or so that we can actually connect to it at a later point. So I'm going to go deploy here, and each deployment needs to have its own URL snippet. Now, what you're providing here isn't the full URI, it's a small portion of it. So I can really just call NN and give it a version. Oh. The other thing we need is the namespace. Now, the namespace is something that is unique to our account. What I want to do here, I'm going to jump back to my account. What I find is the easiest place to find your tenancy namespace is actually here under Storage, Buckets, and just jump into a bucket. And my namespace is here. I'm going to record that off into my notes, close that down, and jump back into the deployment here. So I need to put there my namespace, and okay. And now because I have another model that's showing a zero error, I'm going to deploy that one as well. The URI, I'm going to take SVM version 1.0 and namespace. Okay, so now I've got two models that have been deployed. If I go up here to the OML navigation models, deployments, I can see that those are both active, and I can see the parameters here. The next segment I'm going to do is we're actually going to dive into some code, some Python code, to be able to call into these models and start doing some inference based on them, because in essence, having a model is great, but it doesn't do you any good unless you can actually call it. In the last segments, we trained and deployed the model using Autonomous Database. Now that model is now available to call from code because it's been deployed. Next thing I want to do is fire up some Python code and call the model for inferencing so you can see how that's done. I'm going to use Python because it's quick and easy, and since all the interactions are going to be via REST, you can actually use any language you want to invoke the model. You don't need any SDKs or anything like that. You could even use curl to invoke the calls manually if you wanted to. Ultimately, this code is going to be included in an OCI function for a learning project that I'm putting together. One note here, the code that I have and I'm going to show in a minute is sample code, so I'm really just hard coding the database credentials. If you're watching this, by the time the video gets posted, the database is going to be deleted, so please don't try and connect to my database. Also, as usual, you should put the configuration values into something like OCI Vault. Don't hard code them into your application. But, do what I say, not what I do, right? All right, so here we are in the code editor once again, and you can see this is a Python file. I'm going to start by importing requests. You do have to use pip to install this, and this is just the functionality required to do all of the REST requests. Now, first thing I'm going to do is bring in some code that sets up the variables we're going to use. This is the username and password for the database that I set up, the AI user. Obviously, you don't put this in your code normally, but for a quick test, it's fine. I do have my OML server, and this is based on the region that you are deploying into. So I've used Ashburn. This will change if you've deployed into a different region. And as you can see, we're using HTTPS. So later on, when we traverse credentials, they will be encrypted. You do need the tenancy OSID. This is unique to your particular account. And the database name, you can get that. That's the name that we created, that was created here. Keep in mind, it is the database name, not the display name. Now, in my case, they are the same, but it is possible that they're not the same in your setup. Token is just a variable we're setting up for later use, and then the endpoint name of NN. If you remember back from here, we go view all database actions. From database, we're going to open up machine learning. And then from here, you've got models. And this will be all the models that were created when you did your experiment. And in deployments. So what we want here is the URI snippet, which is 2 capital N's for my, this is my neural network deployment. All right, so I'm going to put that there. Those are the variables I need. The next thing I need to do is get my authentication token. Okay, we are using OAuth authentication tokens to get access to those deployments. So I'll put that here. So I'm going to format the URL as the server, and you can see here we're going to OAuth 2. I'm going to pass in the headers, so the application JSON header, and the data is going to be the username and password as a grant. And then what I'm going to do is post that off to the endpoint and get back a token response. If everything goes well, I get back an OAuth token that I can use in my later calls. If it doesn't, obviously that's not going to work. It's all pretty standard code. The next thing I want to do is actually call the scoring model. So I'll bring this code in here. So scoring the model, I've got, again, the URL. I'm passing in the endpoint name and then score. The headers, again, we're passing in the bearer token. That's going to do the authentication for us. And then the content is application JSON. The next thing is going to be the scoring data. Now, these are the elements that are being used by the model to predict what the outcome is. Okay, in this case, we're predicting the anomaly flag. If I jump back here and go back to our experiments, predict failure, you can see here that temperature C is what had the impact and what the decision is based on. If I go back to my models, so I'll open up the specific details for the neural network model. If I scroll down here, I can see the attributes that are being passed in, the attributes that the model is requiring, and that is temperature C. You can see it's a number, and the format is a double. So back in my code, you can see they're passing in input records, temperature C, and it'll be a double. We'll say it's 3.2 as the variable. And then I'm going to post the request out to the model and get the response back. And then from here, I'm just going to put out the results. Okay, let's set a breakpoint. Let's save the file and we'll run and debug. So here I'm going to actually make the call out to get our grant, which is the token response. And you see there we succeeded. And then we're going to pass in the temperature here, 3.2. And we're going to score the response. And let's see what happened. You can see here. Now the result is, in this case, we're checking to see whether this is an anomaly. Now I know by looking at the data, any result that is above 3 but below 5 is not considered an anomaly. So we can see the result here is a negative value. So it's negative 0.001, which is pretty far away from 1. It means it's got a very low chance of being an anomaly. We run it again, and let's say we pass this in as a 7, so 7 degrees, which should be considered an anomaly because it's well above the threshold that we're expecting. Once again, we're going to step through the code. Now our result, which again is a 7, which is above the acceptable range for temperatures, and we're getting a score here, regression, that is well above 1. So it is accurately predicting if that temperature should be considered a regression or not, based on how far away it is from our accepted normals. So there you go. Now you've got a model that's deployed, and you can quite easily send the code up. You can send a request up to get a scoring result back from that model. All right, now, just to tie this all together. In this video, we set up an autonomous AI database. We imported some sample data. We built and trained 5 different models on that data and evaluated which model performed best. We then deployed the best 2 models into our database, and then finally we were able to call the models from our code. Now, the AI decision logic for this use case was extremely simple. If the temperature is between 3 and 5 Celsius, things are good. If not, they're bad. You would never actually use AI for this because it's a very simple if statement in any programming language, and you should never use AI for something that can be implemented in 1 line of code. However, this was not intended to be a tutorial on AI use cases. It was to show you how easily you can deploy and leverage AI in your applications from Autonomous Database. The process is exactly the same with a more complex use case. It will just take more time to train your model and probably a little bit more data. The content for this video is also available on my blog at basementprogrammer.com. So if you're interested in the code, you can get it there, and that can serve as a printed walkthrough. There are 2 blog posts. The first one is titled, Who Put the AI in My Database? The content is also going to be featured in an upcoming training session that I'm getting ready to publish, so stay tuned at basementprogrammer.com for those details. As always, I hope you found this video and the accompanying blog post have been useful. If you do find my content useful and you like it, please like and subscribe. It helps me to know that you're getting value out of my content. All right, till next time.